Have you ever wondered what the gates of hell might look like? For some, the answer lies in the heart of Ethiopia, in a place called Erta Ale. This isn't just any volcano. It's home to the oldest continuously active lava lake on our planet. But its mesmerizing beauty hides a terrifying power, a lesson learned in the most tragic way possible. Picture this. It's December 2017. A German tourist, drawn by the allure of this natural wonder, ventures too close. He steps onto what he thinks is solid ground, a thin, dark crust of newly cooled lava. In an instant, the ground gives way. He plunges into the molten rock below, a horrifying end in one of Earth's most extreme environments. This tragedy is a stark reminder that Erta Ale, which in the local Afar language means the smoking mountain, is not a gentle giant. It's a living, breathing, and incredibly dangerous force of nature. To understand Erta Ale, we have to travel to its home, the Danakil Depression. This isn't just a location. It's a geological battleground. It's one of the lowest, hottest, and driest places on Earth, often called the crucible of creation. Here, three massive tectonic plates, the African, Somali, and Arabian plates, are in a slow-motion tug-of-war tearing the continent apart. This process, known as rifting, thins the Earth's crust, allowing magma from deep within the mantle to surge upwards. Erta Ale sits directly on top of this rift, a chimney venting the planet's inner fire. The volcano itself is a shield volcano, which means it's not a steep, conical mountain like you might imagine. Instead, it's a broad, gently sloping dome built up over millennia by countless flows of fluid basaltic lava. It stretches over 30 miles in diameter, but rises only about 2,000 feet above the desolate salt flats that surround it. At its summit are two craters, and within the southern crater lies the main event, the lava lake. This isn't a temporary feature that appears and disappears. For at least a century, and likely much longer, this lake of fire has been churning. Geologists believe it's been continuously active since at least 1906. Imagine a cauldron, hundreds of feet across, filled with liquid rock at over 2,000 degrees Fahrenheit. The surface is a constantly shifting mosaic of black, silver, and brilliant orange. Dark crusts form, only to be torn apart by upwelling currents of hotter magma from below, creating fiery cracks that look like veins on a glowing beast. Gas bubbles burst, flinging molten rock into the air like demonic fireworks. The sound is a symphony of the Earth's raw power, a deep, rumbling hiss, punctuated by the crackle and pop of cooling lava. It's a hypnotic, almost primal spectacle. But why here? What makes this lava lake so persistent? It's all about plumbing. Erta Ale has a remarkably stable and direct connection to a magma chamber deep beneath it. This creates a convection system, much like a pot of boiling water on a stove. Hotter, less dense magma rises to the surface, releases gas and heat, cools, becomes denser, and then sinks back down along the edges of the lake. This constant circulation keeps the lake in its liquid state, a window into the dynamic processes happening miles below our feet. For scientists, Erta Ale is an invaluable natural laboratory. Studying its lava provides clues about the composition of the Earth's mantle. Monitoring its gas emissions helps us understand volcanic processes and predict eruptions. The patterns of crust formation and destruction on the lava lake's surface are even used as a small-scale model to understand plate tectonics itself. It's like watching continental drift and fast forward. The journey to Erta Ale is an adventure in itself. It involves a grueling trek across a harsh, otherworldly landscape of salt pans and volcanic rock, under a relentless sun. The region is home to the Afar people, nomadic pastoralists, who have adapted to survive in one of the most inhospitable climates on the planet. They have lived alongside the smoking mountain for generations, their lives and legends intertwined with its fiery breath. For them, the volcano is a powerful sacred entity. As night falls on the crater rim, the real magic begins. With the sun gone, the lava lake illuminates the sky, casting an ethereal, pulsating red glow against the darkness. The heat radiates upwards, a physical presence you can feel on your skin even from a safe distance. Standing there, you feel profoundly small, a temporary visitor witnessing a process that has been going on for eons and will continue long after we are gone. You're not just looking at a volcano. You're watching the Earth being born. The 2017 tragedy was a brutal reminder of the respect this place demands. It led to stricter safety protocols, with designated viewing areas and mandatory guides ensuring visitors don't make the same fatal mistake. But the allure of Erta Ale remains undiminished. It draws adventurers, scientists, and dreamers who want to come face to face with the raw, untamed power of our planet. So, while we might call it the gateway to hell, Erta Ale is also a place of profound creation. It's a testament to the violent, beautiful, and relentless forces that shaped our world and continue to shape it today. It's a living, breathing piece of geological history, a lake of eternal fire that burns brightly in the heart of the African continent, reminding us of the incredible power simmering just beneath our feet. Thank you so much for watching. If you are fascinated by this journey to the heart of the Earth, don't forget to like this video and subscribe for more adventures into the world's most incredible places. See you next time. Standing at the crater's edge, and many have, though it requires a grueling trek through one of the world's most hostile deserts. You can feel the heat on your face from dozens of feet away. You can hear the lake murmur and crack. You can smell the sulfur, sharp and acrid, carried on the wind. And you realize something humbling. This is not a spectacle created for human eyes. This is the Earth doing what it has done for billions of years, indifferent to observation, indifferent to wonder. We are merely visitors to a process far older and far greater than ourselves. But why here? Why does Erta Ale burn when so many other volcanoes sleep? The answer lies in the mechanics of the rift. As the African and Somali plates pull apart, magma from the mantle rises to fill the void. Most of it solidifies underground, forming new crust. But at certain weak points, fractures, fissures, pathways worn smooth by centuries of use, the magma finds its way to the surface. Erta Ale is one of those pathways. A geological chimney, a vent, a throat through which the Earth exhales its inner fire. And as long as the rift continues to open, as long as Africa continues to split, Erta Ale will continue to burn. The smoking mountain does not ask for our understanding. It simply is. And that, perhaps, is the most humbling truth of all. For centuries, Erta Ale belonged to the Afar alone. They did not study it. They did not measure it. They did not attempt to explain its existence through equations or theories. They simply knew it, lived with it, respected its permanence and its power. To the Afar, the mountain was more than geology. It was part of the spiritual landscape, a place where the boundaries between Earth and the otherworldly became thin. The elders told stories of jinn dwelling in the flames, of spirits that rose with the smoke, of ancestral voices carried on the sulphurous wind. Whether these were metaphors or genuine belief mattered little. What mattered was the acknowledgement that Erta Ale was not a place for casual approach. It demanded reverence, it demanded caution. And for generation after generation, that understanding kept people alive. The modern world, however, operates differently. In the 20th century, as European explorers and scientists began mapping the most remote corners of Africa, the Danakil Desert remained one of the last blank spaces on the map. Too hot, too dry, too dangerous. But the rumors persisted, whispers of a mountain that glowed at night, a volcano that never slept. In 1906, the first documented European expedition reached the Erta Ale region. They did not summit. They observed from a distance, noted the strange orange glow on the horizon, and wisely chose not to investigate further. The heat, the lack of water, the hostility of the terrain all conspired to keep the mountain's secrets safe a little longer. It would be another 60 years before serious scientific study began. In 1967, a team of volcanologists finally reached the summit of Erta Ale. What they found astonished them: a lava lake. Not a temporary pool formed during an eruption and soon to cool, but a permanent, active body of molten rock, constantly churning, constantly glowing. At the time, only a handful of such lakes were known to exist anywhere on Earth: Kilauea in Hawaii, Mount Erebus in Antarctica, Nyiragongo in the Congo. But Erta Ale was different. It was older, more stable, more persistent. The scientists measured temperatures, collected gas samples, photographed the roiling surface. They tried to estimate how long the lake had been active, but the Afar guides could offer no beginning point. It had always been there, as long as memory stretched, perhaps longer. What fascinated the researchers most was not just the existence of the lake, but its behavior. Unlike explosive volcanoes that build pressure and release it in catastrophic eruptions, Erta Ale operated on a principle of constant equilibrium. Magma rose from below at roughly the same rate it cooled and sank back down. Gas escaped steadily rather than accumulating to dangerous levels. It was a system in balance. A geological perpetual motion machine. Of course, perpetual motion does not truly exist. Energy must come from somewhere. And in this case, it came from the relentless tectonic forces pulling the African continent apart. As long as the rift continued to widen, a process that occurs at the glacial pace of about half an inch per year, fresh magma would continue to rise. Erta Ale was not defying the laws of physics. It was obeying them perfectly. But understanding the mechanics did not diminish the awe. The volcanologists who stood at the crater's edge in those early expeditions described an experience that transcended science. The heat that baked their faces. The roar of gas venting from the lake. The way the molten rock glowed brighter as darkness fell, turning the crater into a natural amphitheater of fire. One researcher wrote in his journal, "We have seen the heart of the earth beating, and it is both beautiful and terrifying." Another noted, "Standing here, you realize how thin the crust beneath our feet truly is. How fragile our existence. How temporary our cities and our civilizations. This lake was here before humanity learned to speak. It will be here long after we are gone." Yet even as scientists began to unlock Erta Ale's secrets, the mountain reminded them that it was not a museum exhibit. It was a living, dynamic system. In 1973, the lava lake overflowed its crater. Not explosively, but steadily like a pot boiling over. Lava spilled down the northern flank of the volcano, destroying seasonal Afar camps and forcing herders to flee with their animals. No one died. The Afar knew how to read the mountain's moods. They saw the increased glow, smelled the stronger sulfur, felt the tremors in the ground. They moved before the lava reached them. But the event was a reminder. Erta Ale might be predictable in its persistence, but it was not tame. It could still surprise, still threaten, still demand respect. Through the 1970s and 1980s, sporadic expeditions continued. Each brought back new data, new measurements, new photographs and film footage that mesmerized audiences in Europe and America. The Smoking Mountain was no longer a local legend. It was becoming a scientific curiosity, a destination for the bold and the brave. But access remained difficult. The Ethiopian government, embroiled in internal conflicts and political instability, had little interest in promoting tourism to one of the most remote and inhospitable corners of the country. The Afar region was dangerous for other reasons too. Banditry, territorial disputes, the ever-present risk of heatstroke and dehydration. Erta Ale remained, for most of the world, a distant wonder. A place glimpsed in documentaries but rarely experienced firsthand. And perhaps that was for the best. Because some places are not meant to be conquered. Some places are meant to remind us of our smallness, our fragility. The vast indifference of the forces that shape our planet. Erta Ale was one of those places. A fire that burned before we arrived. A fire that will burn long after we are gone. The mountain did not need witnesses to exist. But for those who witnessed it, nothing would ever be quite the same. To truly comprehend Erta Ale, we must descend beneath the surface, beneath the desert floor, beneath the crust itself. Because what burns at the summit is merely the visible expression of forces operating on a scale almost beyond human imagination. The East African Rift is not a scar. It is a birth. Geologists call it a divergent boundary, a place where tectonic plates move apart rather than collide. But that clinical term fails to capture the profound transformation underway. Africa is splitting in two. Slowly. Inexorably. At a pace measured in millimeters per year. But with absolute certainty. The process began roughly 30 million years ago, though the exact timeline remains debated. What is clear is that deep within the Earth's mantle, a massive plume of superheated rock began rising toward the surface. Mantle plumes are geological anomalies, columns of abnormally hot material that ascend from near the core mantle boundary, punching through the overlying rock like a blowtorch through ice. When the plume reached the base of the African plate, it began to melt the crust from below. The plate, unable to withstand the heat and pressure, began to dome upward. Cracks formed. Fissures opened. Magma found pathways to the surface. The Ethiopian highlands rose. Volcanoes erupted. And the continent began its long, slow divorce. Today, the rift extends over 4,000 miles from the Red Sea in the north to Mozambique in the south. But the Afar Triangle, where Erta Ale stands, occupies a unique position in this grand drama. Here, three plates meet. The African plate, the Arabian plate, which is already separated and drifted away, creating the Red Sea, and the Somali plate, which is in the process of breaking free. The Afar Triangle is what geologists call a triple junction, a point where three tectonic boundaries converge. It is among the most geologically active places on Earth. The mechanics are elegant in their simplicity. As the plates pull apart, the crust thins. The mantle rises closer to the surface. Pressure decreases. And when pressure decreases, rock melts. Not because it gets hotter, necessarily, but because the melting point drops. This is decompression melting. The same process that creates the mid-ocean ridges hidden beneath the Atlantic and Pacific. The same process that builds new seafloor inch by inch, century by century, but in afar it happens on land. In plain view, we are witnessing in real time the birth of a new ocean. If the current rate of spreading continues, and there is no reason to believe it will not, in 10 million years, the Somali plate will have separated entirely from the rest of Africa. The Indian Ocean will flood into the widening gap. A new sea will divide the continent. Somalia, Kenya, Tanzania, and parts of Ethiopia will become an island, a new Madagascar. Erta Ale, if it still exists, will stand on the shore of that infant ocean, perhaps beneath its waves. Perhaps as a seamount glowing in the depths. But that is the distant future. Today, we witness only the beginning. The magma that feeds Erta Ale comes from approximately 20 to 30 miles below the surface. Not as deep as some volcanic systems, but deep enough to remain perpetually molten. It rises through a complex network of fractures and conduits, driven upward by buoyancy and pressure. The exact pathway is unknown. Volcanoes do not reveal their plumbing easily. But what is clear is that the supply is constant, uninterrupted. As long as the rift continues to open, as long as the mantle continues to rise, Erta Ale will have fuel. The lava itself is basaltic, the most common type of volcanic rock on Earth, dark, dense, rich in iron and magnesium. It is the same material that forms the ocean floor, the same material that built the Hawaiian Islands, the same material that, cooling slowly in the depths, forms the foundation of continents. Basaltic lava is fluid. It flows easily, unlike the thick, viscous lava of more silica-rich volcanoes. This fluidity is why Erta Ale can sustain a lake rather than simply plugging its own throat with solidified rock. The lava emerges at temperatures between 1800 and 2000 degrees Fahrenheit, hot enough to glow white-orange in darkness. Hot enough that standing too close means feeling your skin prickle and burn even without direct contact. But temperature alone does not explain the lake's permanence. The key lies in convection. The lake behaves much like a pot of boiling water. Hot lava rises from below. It spreads across the surface, loses heat to the air, and sinks back down as it cools and becomes denser. This creates a continuous circulation, a churning. The surface is never still. Plates of semi-solid crust form as the molten rock cools, but they are constantly broken apart by the upwelling from beneath. The cycle repeats endlessly, day and night. Year after year, decade after decade, it is hypnotic to watch. Scientists who have spent nights observing the lake describe entering a trance-like state. The mind struggles to process something so alien, so unlike anything in ordinary human experience. Molten rock should not look alive, yet it does. Gas plays a role as well. Dissolved in the magma are various gases, primarily water vapor, carbon dioxide, and sulfur dioxide. As the magma rises and pressure drops, these gases escape, sometimes gently, as small bubbles that pop at the surface. Sometimes more dramatically, as fountains that shoot glowing lava dozens of feet into the air before collapsing back into the lake. The sulfur is what you smell. That acrid, rotten egg odor that clings to your clothes and hair long after you leave the crater. It is unpleasant, certainly. But it is also a reminder of the chemistry underway. A reminder that this is not merely hot rock, but a complex brew of elements and compounds being cooked and released. Erta Ale is not unique because it burns. Many volcanoes burn. It is unique because it burns without pause, without rest. It is a window into the Earth's interior that never closes. A glimpse of processes that usually remain hidden until they manifest as catastrophic eruptions. Here, the violence is diffused, spread across time. made almost gentle by its constancy. And that constancy is both its wonder and its warning, because the same forces that create beauty can, without notice, create devastation. For most of its recorded history, Erta Ale has been remarkably well behaved. The lava lake churns, gas vents, the mountain glows, but it does not explode. It does not rain fire upon the desert. It simply exists, constant and predictable, a geological metronome keeping time in the depths of the Danakil. But constancy should never be mistaken for safety. In September of 2005, the lake broke its pattern. The signs began weeks earlier, though few were present to notice them. The Afar herders, always attuned to the mountain's moods, reported increased tremors. Small earthquakes that rattled cooking pots and disturbed the camels. The glow from the crater grew brighter, more intense, visible from farther away across the desert plain, and the sound changed. The low murmur that had accompanied the lake for decades became a roar, a deep, rumbling growl that seemed to emanate from the bowels of the earth itself. Something was rising. On the night of September 4th, the lava lake overflowed. Not slowly, as it had in 1973, not gently. This time the lake surged. A fountain of molten rock erupted from the crater, shooting hundreds of feet into the night sky. Lava bombs, fragments of semi-solid rock torn from the fountain, rained down on the crater rim and the slopes beyond. Then the real flow began. Lava poured over the northern edge of the crater like water breaching a dam. It cascaded down the mountainside in rivers of fire, following ancient channels carved by previous eruptions. The flow was fast by Erta Ale standards. Several miles per hour, slow enough to outrun, but relentless. Everything in its path ignited or melted. Sparse vegetation. The few stunted trees that clung to life in sheltered ravines. The temporary camps of Afar families who had made the mistake of settling too close. The Afar fled into the darkness, driving their livestock ahead of them. They had no vehicles, no rescue helicopters. Only their knowledge of the terrain and their ability to move quickly on foot. They survived. All of them. But the lesson was clear. Erta Ale could still surprise. Could still threaten. The lake's constancy was not a guarantee of its docility. The eruption continued for 3 days. By the time it subsided, fresh lava covered over 2 square miles of the northern flank. The summit had changed shape. The crater rim, already unstable, had partially collapsed on the northern side, widening the bowl that contained the lake. When scientists returned months later to assess the damage, they found the lava lake still active. Still glowing, as if nothing had happened. But something had changed. The 2005 eruption marked the beginning of a new phase in Erta Ale's behavior. Over the following years, the lake became more dynamic, more unpredictable. In 2007, another overflow. Smaller than 2005, but still significant. Lava flows extended down the eastern flank, reaching areas that had not seen fresh lava in living memory. In 2010, the lake level dropped suddenly. Not gradually, as it sometimes did, but dramatically. Within days, the surface of molten rock had descended nearly 100 feet deeper into the crater, leaving behind walls of fresh, still glowing solidified lava. Scientists speculated that a new conduit had opened somewhere beneath the mountain, draining magma laterally rather than upward. But without seismic monitoring equipment, difficult to install and maintain in such a remote, hostile environment, they could only theorize. Then, just as suddenly, the lake refilled. The magma rose again. The glow returned to its familiar intensity. Erta Ale was reminding everyone that it operated on its own schedule, by its own rules. The most dramatic event came in January of 2017. A fissure opened on the southern flank of the volcano, several hundred feet below the summit. It was not connected to the main crater, not directly. But it was fed by the same magma source, the same geological plumbing that sustained the lake. Lava fountains erupted from the fissure, creating a curtain of fire along the fracture line. The eruption was explosive by Erta Ale's standards, loud, violent, spectacular. And it lasted only hours. By the next morning, the fissure had sealed itself. The lava cooled. Silence returned. But the event was significant because it demonstrated that Erta Ale's activity was not confined to the summit crater. The entire mountain, the entire volcanic system, remained restless. Magma could find new pathways, new outlets. The predictability that had defined Erta Ale for so long was eroding. For the Afar people, these changes were deeply concerning. Their survival depended on understanding the mountain, on reading its signals, on knowing when to approach and when to retreat. But if the mountain was becoming less predictable, their traditional knowledge passed down through generations might no longer be sufficient. Some families moved their seasonal camps farther from the volcano. Others debated whether to abandon the region entirely, despite its importance for grazing and salt trading. But leaving was not simple. This was their homeland, the land of their ancestors. The Danakil might be harsh, but it was theirs. And so they adapted, watched more carefully, relied more heavily on the few scientific teams that occasionally visited, hoping for advance warning of future eruptions. The scientific community, meanwhile, struggled with a fundamental problem. Erta Ale was one of the most fascinating and important volcanoes on Earth, but it was also one of the least monitored. Installing permanent seismic stations, gas sensors, and thermal cameras required funding, equipment, and most crucially, security. The Afar region was not politically stable. Access was difficult. Maintenance was nearly impossible. Most of what scientists knew about Erta Ale came from brief expeditions, a few days or weeks on the ground, gathering data, then retreating before supplies ran out or conditions became untenable. It was like trying to understand a symphony by hearing only scattered notes. They knew the lake was active. They knew the magma system was complex. They knew eruptions could occur with little warning. But they did not truly understand why the lake had persisted for so long, or why, after decades of stability, it was now becoming erratic. The mountain held its secrets close. And then, in 2017, something happened that would change Erta Ale's story forever. Not an eruption, not a scientific breakthrough, a tragedy. On the night of January 14th, the mountain reminded the world that fire does not forgive carelessness, and that some lessons can only be learned in blood. By 2017, Erta Ale had become something it had never been before, a tourist destination. The rise of adventure tourism in the early 21st century brought a new kind of visitor to the Danakil Desert. Not scientists with instruments and research permits. Not aid workers or government officials, but travelers. Seekers of extremes. People willing to pay significant sums for the privilege of standing at the edge of the Earth's most accessible window into hell. Tour companies in Ethiopia began offering expeditions. Multi-day treks across the desert, culminating in a night spent at the crater rim, watching the lava lake glow beneath the stars. It was marketed as the experience of a lifetime, and for many it was. But every privilege carries risk. And Erta Ale was about to deliver a brutal reminder. The night of January 14th began like dozens before it. A group of tourists, Germans, Austrians, Ethiopians, had made the arduous journey to the summit. Accompanied by local Afar guides and armed guards, a necessity in a region where banditry remained a threat, they pitched tents on the crater rim, ate a simple dinner, then gathered at the edge to witness what they had traveled so far to see. The lava lake did not disappoint. It churned and glowed, mesmerizing in its alien beauty. Cameras clicked, video rolled. The tourists spoke in hushed, awestruck tones. This was what they had come for. This moment. This proximity to something primal and eternal. No one noticed the tremors. Not at first. Erta Ale had been restless for weeks. The lava lake had risen higher in its crater. The glow had intensified. Small earthquakes had rattled the region, but small earthquakes were normal here. The mountain always trembled. The Afar guides knew something was different. They felt it. An unease they could not quite articulate. But the tourists had paid. The schedule was set. And the mountain had been climbed safely dozens of times over the past years, so they stayed. At approximately 11:30 in the evening, the lake erupted. Not gradually, not with warning. One moment it was churning peacefully. The next, a massive gas bubble burst at the surface with the force of an explosion. A fountain of lava shot 200 feet into the air, illuminating the crater like daylight. Molten rock rained down across the rim. Lava bombs, some the size of basketballs, arced through the darkness, smashing into the ground with dull, wet thuds. Then came the surge. The lava lake overflowed its banks, spilling toward the campsites with terrifying speed. Chaos. Screaming. People running in all directions, stumbling in the darkness, trying to avoid the glowing rivers now snaking across the ground. The guides shouted orders in Afar, in Amharic, In broken English, grab nothing. Run. Just run. But not everyone could. One of the lava bombs struck a Belgian tourist in the shoulder. The impact knocked him to the ground. The heat ignited his clothing. He screamed, rolling, trying to extinguish the flames. Others were hit by smaller fragments. Burns, lacerations, panic. And then the gunfire started. In the confusion, the armed guards, hired to protect against bandits, heard movement in the darkness beyond the camp. Within seconds, a volcanic eruption had become a combat zone. Later, it would be determined that the attackers were indeed bandits. Rebels from an armed faction operating in the region. Whether they had intended to rob the camp or were simply in the wrong place at the wrong time remains unclear. What is clear is that bullets and lava do not distinguish between combatants and innocents. When dawn broke, the mountain was quiet again. The lava lake had returned to its slow churn. The overflow had stopped, leaving behind black tongues of cooling rock. But the campsite was devastated. 5 people had been killed, 2 from lava bombs, 3 from gunfire. Among the dead were a German tourist, a Swiss guide, and 3 Ethiopians, 2 guards and 1 cook. Dozens more were injured, burns, broken bones, bullet wounds. The survivors were evacuated by helicopter once dawn made flight possible. They were flown to hospitals in Addis Ababa, then repatriated to their home countries. Many would bear scars, physical and psychological, for the rest of their lives. The international response was immediate and harsh. News outlets around the world reported the tragedy. Headlines screamed about the dangers of volcano tourism, about inadequate safety measures, about the recklessness of bringing untrained civilians to one of the most volatile places on Earth. The Ethiopian government, already embarrassed by the security failure, suspended all tourism to Erta Ale indefinitely. Tour companies were investigated. Permits were revoked. The mountain once again became off-limits, too dangerous, too unpredictable. The Afar guides, who had spent years learning to coexist with the volcano, were left without income. The delicate balance between respecting the mountain and benefiting from its allure had collapsed in a single, terrible night. In the weeks and months that followed, scientists studied what had happened. They analyzed seismic data from distant stations. They reviewed footage captured by tourists in the moments before the eruption. The conclusion was sobering. There had been signs. Subtle, yes, but present. Increased tremors. A rise in the lake level. Changes in gas emissions. But no one had recognized them as precursors to an eruption because Erta Ale had never behaved this way before. Its eruptions had always been overflows, slow and relatively predictable. This had been explosive, sudden, violent. The mountain had evolved, and no one had noticed until it was too late. The tragedy raised difficult questions. Should volcanoes like Erta Ale be accessible to tourists at all? Could any amount of preparation truly make such a place safe? Or was there an inherent arrogance in believing that nature could be commodified, packaged, made palatable for consumption? The Afar people, who had lived alongside the mountain for centuries, had an answer. They had always known the fire demanded respect, distance, caution. The modern world had forgotten, or ignored, and the mountain had reminded them in the only language it knew. Fire does not negotiate, it does not compromise. It simply burns, and those who forget pay the price. In the aftermath of the tragedy, the world turned its attention away from Erta Ale. The news cycle moved on. The headlines faded. The mountain, once briefly famous, returned to obscurity. But the lava lake did not stop burning. It never does. For the scientists who had dedicated years to studying Erta Ale, the 2017 eruption was not an endpoint but a catalyst. It revealed how little was truly understood about this remarkable system. Why had the eruption been so explosive when the lake typically behaved so gently? What had changed in the magma chamber beneath the mountain? And most importantly, could it happen again? These questions demanded answers, but answers required access. And access in the wake of the tragedy had become nearly impossible. The Ethiopian government's tourism ban remained in effect. Security concerns in the Afar region had intensified. Funding for volcanic research in such a remote, dangerous location was difficult to justify when safer volcanoes existed elsewhere. Yet a handful of researchers persisted. In 2018, a small international team secured permission for a brief expedition. Their goal was modest but crucial: to install remote monitoring equipment that could transmit data via satellite without requiring constant human presence. They trekked to the summit under heavy guard, worked around the clock for 3 days, and retreated before their supplies ran out. The equipment they left behind was rudimentary by modern standards. A few seismometers, gas sensors, thermal cameras, but it was better than nothing. For the first time, Erta Ale would be watched continuously. Not by human eyes, but by instruments that never blinked, never slept, never needed water or rest. The data they transmitted would prove revelatory. The lava lake, it turned out, was far more dynamic than anyone had realized. Its surface level fluctuated constantly, sometimes rising 10 or 15 feet in a single day, sometimes dropping just as quickly. These changes correlated with seismic activity deep beneath the volcano. Tiny earthquakes, too small to feel, but detectable by sensitive instruments, occurred in clusters. Each cluster preceded a change in the lake's behavior. It was as if the mountain was breathing, inhaling magma from the mantle below, exhaling it back into hidden chambers and fractures. The lava lake was not a static pool. It was the visible throat of a vast, complex plumbing system. A system that extended miles into the earth and connected to the broader tectonic forces tearing Africa apart. Understanding the lake meant understanding the entire rift. And understanding the rift meant understanding one of the fundamental processes shaping our planet. But the data also revealed something troubling. The explosive eruption of 2017 had not been an anomaly. It had been a symptom of a deeper change in Erta Ale's magmatic system. Analysis of gas emissions showed an increase in sulfur dioxide and carbon dioxide. These gases, dissolved in magma under pressure, can accumulate until they reach a critical threshold. When that threshold is breached, the result is explosive degassing, the volcanic equivalent of shaking a soda bottle and opening the cap. The 2017 eruption had released built-up pressure, but the pressure was building again. The mountain was not settling down, it was ramping up. In 2019, the lake overflowed again. No tourists were present to witness it. No one was injured. But the flow was substantial. Lava traveled over a mile down the northern flank before solidifying. In 2020, another overflow, and another in 2021. Erta Ale was entering a new phase. More active, more volatile. The stable, predictable behavior that had characterized it for most of the 20th century was gone. Some scientists speculated that the increased activity was linked to broader changes in the East African Rift. Seismic. Studies suggested that magma was rising more rapidly from the mantle, that the tectonic plates were pulling apart slightly faster. Others pointed to localized factors. Perhaps new fractures had opened beneath the volcano, altering the pathways magma traveled. Perhaps the magma chamber itself was refilling after being partially drained during previous eruptions. The truth, as is often the case in geology, was likely some combination of factors. A complex interplay of forces operating on different timescales and at different depths, but the result was undeniable. Erta Ale was changing, evolving, becoming something it had not been before. For the Afar people, these changes were deeply unsettling. Their relationship with the mountain had always been based on understanding, on reading its moods, on knowing when to approach and when to keep distance. But if the mountain's behavior was fundamentally changing, that traditional knowledge became less reliable. Some elders spoke of prophecies, stories passed down through generations about times when the mountain would awaken more fully, when the fire would spread beyond its usual bounds. Whether these were genuine ancestral warnings or retroactive interpretations of current events was impossible to say. But they reflected a real anxiety, a sense that the balance between people and volcano, maintained for so long, was shifting. And yet, life continued. The Afar still herded their camels across the Danakil, still traded salt from the ancient mines, still camped within sight of the mountain because the mountain was part of their world. They adapted, moved camps more frequently, paid closer attention to the tremors and the glow, shared information more rapidly across family networks. They did what humans have always done when living alongside natural forces beyond their control. They learned, adjusted, endured. By 2023, the monitoring equipment installed in 2018 had largely failed. The brutal environment, extreme heat, sulfuric gases, sandstorms, had taken its toll. Some sensors went silent. Others transmitted garbled data. The thermal cameras, encrusted with acidic deposits, could no longer focus properly. A new expedition was planned to replace and upgrade the equipment, but funding remained elusive. The tragedy of 2017 still cast a shadow. Institutions were reluctant to invest in a location that had proven so dangerous. And so, once again, Erta Ale slipped partially out of view, monitored intermittently, understood incompletely. The lake continued to burn, continued to churn, continued to glow in the darkness, indifferent to whether it was watched, indifferent to whether it was understood. Because the truth that scientists, tourists, and even the Afar themselves must ultimately accept is this: Erta Ale does not exist for human comprehension. It does not perform for cameras or conform to models. It is a consequence of geology, a side effect of a continent splitting apart. It burns because the Earth's interior is hot and the crust is thin and the magma has nowhere else to go. It will burn until those conditions change, until the rift moves elsewhere, until the mantle plume shifts or cools or finds a new pathway. That might happen in 100 years, or 100,000, or 1,000,000. On geological timescales, the distinction hardly matters. The lava lake is not a monument. It is not a landmark. It is a process, a moment stretched across centuries. And it will outlast every name we give it, every theory we construct, every attempt to predict or control or understand. It will simply continue until it doesn't, and even that ending will be temporary. Because fire, like the Earth itself, always finds a way to return. There is a question that haunts every researcher who has stood at the edge of Erta Ale's crater. A question whispered in university hallways and research stations, debated over coffee in conference rooms thousands of miles from the Danakil Desert. What happens if the lake dies? Not in eruption, not in violence, but simply stops. What if one day the magma ceases to rise? The lake solidifies. The glow fades. Would we lose something irreplaceable? The answer, uncomfortable as it may be, is yes. Erta Ale is not simply a geological curiosity. It is a laboratory. A natural experiment that has been running uninterrupted for longer than human civilization has kept written records. Nowhere else on Earth can scientists observe the continuous convection of basaltic magma in such an accessible setting. Nowhere else can gas emissions be measured so consistently. Nowhere else does the boundary between solid crust and molten mantle sit so exposed, so vulnerable to study. Every measurement taken at Erta Ale contributes to our understanding of how magma behaves, how gases dissolve and escape, how lava lakes form and persist. And that understanding extends far beyond one volcano in Ethiopia. The principles observed at Erta Ale apply to volcanic systems worldwide, to Hawaii's Kilauea, to Iceland's Fagradalsfjall, to the submarine volcanoes hidden beneath the oceans, where most of Earth's volcanic activity actually occurs. When scientists model volcanic eruptions, when they attempt to predict which mountains might threaten nearby populations, the data from Erta Ale factors into their calculations. When engineers design systems to extract geothermal energy from volcanic regions, they reference convection patterns first documented at lava lakes like Erta Ale's. Even space agencies pay attention. Because understanding how lava behaves on Earth helps us interpret volcanic features on other worlds. On Jupiter's moon Io, where hundreds of volcanoes rage continuously. On Venus, whose surface is dominated by volcanic plains. On Mars, where ancient lava flows shaped the landscape billions of years ago. Erta Ale, isolated and remote as it may be, connects to questions far larger than itself. But knowledge is not the only thing at stake. For the Afar people, the mountain is identity, heritage, a connection to ancestors who walked this land long before nations drew borders or scientists brought instruments. The fire is part of their story, their cosmology, their understanding of the world's workings. To lose it would be to lose a piece of themselves. And so, despite the dangers, despite the unpredictability, despite the tragedy of 2017, the Afar remain. They are the true guardians of Erta Ale. Not by choice, perhaps, but by circumstance and tradition. They are the ones who notice when the glow changes, when the tremors intensify, when the air smells sharper, more sulfurous. They are the ones who guide scientists to the summit when access is permitted, who provide water and food and knowledge of the terrain, who warn when conditions become too dangerous. Without the Afar, Erta Ale would be nearly unstudied, nearly unknown. They ask little in return: respect, fair payment for their services. Recognition that this is their land, their mountain, their fire. Yet they receive far less than they deserve. In recent years, there have been efforts to formalize their role, to train AFAR guides in basic volcanology so they can recognize precursor signs more reliably, to provide equipment, radios, GPS devices, safety gear, that might prevent future tragedies. Some international organizations have pushed for Erta Ale to be designated a UNESCO World Heritage Site, not only for its geological significance, but for its cultural importance to the AFAR. Such designation would bring funding, protection, international oversight. But it would also bring bureaucracy, regulations, external control over a mountain that the AFAR have managed in their own way for centuries. The debate is ongoing, complicated, fraught with tensions between preservation and autonomy, between scientific interest and local sovereignty. There are no easy answers. Meanwhile, the volcano continues its work, indifferent to human politics. In 2024, a small team of volcanologists, Ethiopian, American, and French, launched a new initiative. Using drones equipped with thermal cameras and gas sensors, they could collect data without exposing personnel to the crater rim's dangers. The drones flew at dawn when winds were calmest. They hovered above the lava lake, recording temperatures, measuring gas plumes, photographing the ever-changing surface. The footage they captured was extraordinary. High-resolution thermal imagery revealed convection cells within the lake, patterns of hot and cool rock circulating in real time. Gas sensors detected fluctuations in sulfur dioxide emissions that correlated with changes in the lake's activity. When emissions spiked, overflows often followed within hours or days. For the first time, scientists had a tool that could monitor Erta Ale safely and continuously. A tool that did not require risking human lives. It was progress. Real, tangible progress, but the drones were expensive, difficult to operate in the extreme heat and wind. Their batteries drained quickly. And they required trained operators, people who understood both the technology and the volcano. Scaling up the program would require sustained funding and institutional support. Neither was guaranteed. Still, the mere fact that such efforts were underway was cause for hope, because Erta Ale matters. Not just scientifically, but symbolically. It is a reminder that Earth is not a static backdrop for human activity. It is a living, dynamic system. A planet still forming itself, still churning and burning and changing. We live on a thin crust floating atop unimaginable heat. Erta Ale is where that truth becomes undeniable. Standing at its edge, watching molten rock that was, until moments ago, buried miles beneath your feet, you understand viscerally what most people only know intellectually. The ground beneath us is not solid, not really. It is temporary, fragile, a skin stretched over fire. And perhaps that understanding is the greatest gift Erta Ale offers. Not data, not tourism, not even beauty, though it possesses that in terrible abundance, but humility, the recognition that we are small, that our cities and technologies and ambitions are built on a foundation that owes us nothing. They do not need reminders, but the rest of the world does, and Erta Ale provides it for those willing to listen. The lake burns not for us, but in spite of us. It is indifferent to our curiosity, our reverence, our fear. It simply is. And in that indifference lies a truth more profound than any scientific paper could capture. We are visitors here, guests at a spectacle that predates us and will outlast us. The fire does not need guardians, but we need it to remind us what we are and what we are not. In the final accounting, what can be said about a lake of fire that has burned for over a century without pause? What conclusion can we draw from magma that refuses to cool, from a mountain that breathes when others sleep? Perhaps only this: Erta Ale is not an exception to the rules of geology. It is a perfect expression of them. Everything about this volcano makes sense once you understand the forces at work. The tectonic plates pulling apart, the mantle rising to fill the void, the magma finding pathways to the surface. There is no mystery, really. No magic. Just physics, chemistry, the remorseless logic of heat and pressure and density. And yet, knowing the mechanisms does not diminish the wonder. Because understanding how something works and truly comprehending it are different things entirely. You can read about convection currents in textbooks. You can study thermal dynamics and gas dissolution and crystallization temperatures. But none of that prepares you for the moment you stand at the crater's edge and watch the Earth's interior made visible. Watch rock behave like liquid. Watch fire that has no fuel yet never extinguishes. The mind rebels against it, searches for familiar frameworks, finds none. And in that moment of dislocation, something shifts. Some certainty about the world's solidity cracks just slightly. The future of Erta Ale is, in one sense, assured. As long as the African continent continues to split, and it will, for millions of years to come, the Danakil Depression will remain volcanically active. The rift will widen. The crust will thin. Magma will rise. Erta Ale itself may change. The current crater may collapse and reform elsewhere on the mountain. The lava lake may drain temporarily, only to reappear years or decades later in a new location. These are the rhythms of volcanism: birth, death, rebirth. But the fire itself will not die. Not permanently. Not on any timescale that matters to human civilization. What is less certain is humanity's relationship with that fire. Will we learn to coexist respectfully as the Afar have done for centuries? Will we continue to monitor and study without exploiting or endangering, or will we repeat the mistakes of 2017? Allow curiosity to override caution? Treat the volcano as a commodity rather than a force of nature that demands deference. The answer depends not on the mountain, but on us. Erta Ale will continue regardless. It does not require our approval or our presence, but we perhaps require it. As a reminder, a teacher, a window into processes that built the very ground beneath our cities and homes. In recent years, there has been talk of establishing a permanent research station near Erta Ale, not on the summit where the dangers are too great, but at a safe distance. A base where scientists could work for extended periods, monitoring the volcano continuously, responding quickly to changes. Such a station would represent a commitment, an acknowledgement that some places are worth studying not for profit, not for tourism, but for understanding. It would also represent partnership, because any permanent presence in the Danakil would require cooperation with the Afar, their knowledge, their consent, their participation. Whether funding will materialize for such an ambitious project remains uncertain. Volcanology has never been lavishly supported. And Erta Ale, remote and dangerous, is a difficult sell to grant agencies and governments. But the dream persists among those who have dedicated their careers to understanding this remarkable place. Meanwhile, the lava lake turns on. Night after night, it glows against the desert darkness, a beacon visible for miles. A reminder that beneath the stillness, beneath the silence of the Danakil, the earth is anything but dormant. The Afar still camp in its shadow, still tell stories about the fire that never sleeps, still guide their children past the mountain, teaching them to read its moods, to respect its power. And occasionally, when security permits and circumstances align, small groups of scientists make the trek to the summit. They set up their instruments, they take their measurements, they photograph the lake from every angle. Then they descend, return to their universities and laboratories, analyze their data, publish their papers. And the mountain, left alone again, continues its ancient work. There is something poetic about that constancy, something almost comforting. In a world where so much changes so rapidly, where technology and society evolve faster than we can fully comprehend, Erta Ale remains. It burned before the internet, before flight, before electricity, before the Industrial Revolution. It burned when humans first left Africa, spreading across the continents. It burned when civilizations rose and fell, when empires conquered and crumbled, when languages were born and died. It will burn when we are gone, when our cities are dust and our satellites have fallen from orbit and our names are forgotten. And that, strangely, is not a depressing thought. It is a freeing one, because it means that some things are larger than us, more enduring, more fundamental. We spend so much of our lives focused on the immediate, the urgent, the concerns of this year, this decade, this century. But Erta Ale operates on a different timescale, one that measures change in millennia, not minutes. Standing at its edge forces perspective, forces you to zoom out, to see yourself not as the protagonist of existence, but as a brief witness to processes that preceded you and will continue long after. It is humbling and necessary, because humility is what allows us to learn, to adapt, to survive. The Afar understand this. They have built their entire culture around coexistence with forces they cannot control. They do not conquer the desert. They move through it. With it. Perhaps that is the final lesson Erta Ale offers. Not domination, but coexistence. Not control, but respect. The fire will burn, the lake will churn, the mountain will breathe. We can choose to watch, to study, to marvel, but we cannot stop it. Cannot own it, cannot tame it. And maybe that is exactly as it should be. Because in a world increasingly shaped by human hands, there is profound value in places that remain wild, ungoverned, unyielding. Places that remind us what Earth was before we arrived, and what it will be when we are gone. The lava lake at Erta Ale is not the deepest in the world by vertical measurement, but it is among the oldest, the most persistent, the most accessible. It is a fire that has burned longer than memory, and it will burn longer than prophecy. It is not ours to understand completely, only to witness, to respect, to learn from, and perhaps, if we are wise, to let burn in peace. The smoking mountain stands. The fire never sleeps. And in that constancy lies a truth more ancient than words. We are not separate from the earth. We are made of it, shaped by it, sustained by it. Erta Ale does not teach with language. It teaches with fire. And the lesson is simple. Respect the ground beneath your feet. It was forged in flames. And to flames it will, one day, return.